I'll assume before you watch this video that you've watched the previous video or went on YouTube to find other examples to refresh yourself about how the gold particle or gold foil experiment works. As a really brief reminder, you've got your alpha particle, which is moving, and it is heading towards a piece of gold foil. And this piece of gold is stationary. So we want to know how close the alpha particle is going to get to the gold particle before being forced to move backwards, or however it's going to move. Well, let's think about what's happening here. We know initially we've got some kinetic energy from the alpha particle moving, and eventually that's going to slow down, and it's going to slow down and turn into electrostatic energy. So therefore we know we've got 1/2 mv squared is equal to k q1 q2 over r squared. Over r. That's for forces. We're looking for like radius basically, so let's just do some switches. We've got our r is equal to 2k q1 q2 over mv squared. So let's list out our information, see what we know. Well, we know that our q1 we'll just say is our alpha particle, which means it's 2 times the charge of a typical electron, which is 1.6 times 10 to the negative 19c, which is going to be equal to 3.2 times 10 to the negative 19. Our Q2, we're going to make gold, which is 79 times the charge of 1.6 times 10 to the negative 19. This is going to be equal to 1.3 times 10 to the negative 17 charge. Our mass, we've got listed up here, and our speed, we've got listed right here. So we can just go ahead and plug in. And when we put all that into our calculators, we end up getting an answer of 4.2 times 10 to the negative 14 meters.